Today we're going to discuss very briefly certain aspects about the periodic table. Now we will go by far more in depth on the periodic table in the next couple of weeks. This is just a scratch the surface version showing you some of the most basic ideas about the periodic table. So, in this introduction to the periodic table, the vertical columns of the periodic table are called groups or families. Groups or families. Sometimes these groups or families have special names. We'll talk about alkali metals. We'll talk about alkaline earth metals. So sometimes they have specific group names. Other times we just simply refer to them as, for instance, the oxygen family. Okay, so if you find oxygen on your periodic table, it's atomic number 8. If you find oxygen and you go down that column vertically, okay, oxygen, sulfur, selenium, tellurium, okay, those are the oxygen family. So sometimes we name them just by the top element of that group. Sometimes they have their own unique names. We'll get into those names later on. Each group contains elements that have similar chemical properties. Similar chemical properties. And these chemical properties are the basis of the periodic table. There is a rhyme, there is a reason to the periodic table. Mendeleev and then Moseley came together, put these together, and one of the biggest things was the similar chemical properties. Now this is just saying here, folks, you know, if you look at beryllium, magnesium, calcium, strontium, barium, radium, that is all the second group on your periodic table. So this is just telling you that they are all reactive metals with very similar abilities to bond with other kinds of atoms. You'll learn later on that this group all have 2 valence electrons. That helps their bonding properties out, whether they want to accept or donate electrons. In this case, these guys want to donate electrons. So that whole group, and it's called the alkaline earth metals, have similar chemical properties. Right there is that group, okay? All the way top down, the one I was just talking about. Beryllium, magnesium, calcium, strontium, barium, radium. Okay, group 2, as we call it on the periodic table, the alkaline earth metals. Like I said, you'll learn more in depth later on. Horizontal rows on your periodic table are what we call periods. Throughout a period, elements that are closer to each other in the same period tend to be more alike. They are more similar to each other than if they would happen to be farther apart. So, if we look here, here's a period, okay? And I'm going to bring up the next slide, and it's talking about the second period right here that's in orange. These two elements in the second period are more similar to each other than these elements over here, and vice versa. These elements are more similar to each other than the ones on the total left side of the table. Okay? They don't have common properties as much as what the up and down, the vertical groups do, but they're still more similar in that means. So, as I look at this, okay, as I look at this, let me go back. Like I said, these two groups on this period are more similar than the ones all the way over here. You'll understand that a little bit more when we talk about metals and nonmetals. The two sets of elements placed below the periodic table make up what we call the lanthanide and actinide series. The lanthanide and actinide series. These metallic elements fit just after element 57 and element 59. So point on your periodic table, well, where element 57 and element, I think I said 59, I meant 89. Element 57 and element 89. Find those on your periodic table. Notice they have the little star and the double star in their boxes. That is where 57 and 89, that is where the lanthanide and actinide series fit in. Now, element number 57 is lanthanum. So, 58 through 71 are the lanthanide series. Actinium is number 89. So the actinide series is number 90 through 103. Now, the only reason that we put those at the bottom of the table is to make the table more concise. So we can fit it on to a sheet of paper very neatly like you have in front of you. Imagine if we would squeeze that out and have those 14, then that periodic table would be pretty big. So in order to make it more concise so we can fit that onto a better table for you to view, we put those down below. Lanthanide and the actinide series. Right here you see a diagram that has both of those, okay, the lanthanides and the actinides, and once again, they fit in right around here, okay, in periods 6 and 7 on your table. Now let's discuss some types of elements that you'll see on here. We have 3 different types of elements on this periodic table. Metals, and we're going to list some properties of metals. They have a metallic luster. Okay, a metallic luster, that means they're shiny. A metallic luster, the shine they have. Metals conduct both heat and electricity. Probably most of the houses that we live on are wired with copper because copper is a great conductor of electricity. Copper is a metal. They are solids at room temperatures. And what I mean by this is most, excuse me, most of these are solids at room temperature. If you look at your periodic table, let's take a glance at the key down at the bottom. I'm looking right under element number 90. You can see color codes. And it says that black is a solid, red is a gas, blue is a liquid, and if it is outlined, it means that it is synthetically prepared. Now, what those mean is at room temperature, what that element will be. And what you're going to see, okay, I want you to find mercury, number 80. Notice mercury is blue, right? So that tells you mercury at room temperature is a liquid. Okay, so not all metals are solids at room temperatures. Most of them are. If you were going to guess, you would be pretty safe to guess that if it's a metal, it's a solid, because most are solids at room temperature. But there are a couple of exceptions. Metals are what we call malleable. Malleable means that it can be hammered or rolled into thin sheets. Anybody know what a mallet is? What's a mallet? A what? Like a rubber hammer, okay? So just when I think of malletable, I think of mallet, and you can hammer it into a sheet. Have you ever dealt with something like aluminum foil? That's a pretty thin sheet, isn't it? Okay. It's a pretty thin sheet, that aluminum foil. Ductile. Metals are ductile, meaning that they can be drawn or rolled into a fine wire. I just said earlier, copper wiring is what most of the houses have because it's such a good conductor of electricity. Okay, it's such a good conductor of electricity, and it is ductile, rolled into a wire. Metals also have a very high tensile strength. A very high tensile strength, meaning that they have the ability to resist breaking when pulled. Let's stop and think. If I had a rubber band in my hand and I was pulling it apart, would you think that it has a very high tensile strength? Would I be able to break a rubber band? Absolutely. That has a low tensile strength. Now that same copper wire we were talking about, do you think I could pull that apart? It'd be a little bit tougher to do, wouldn't it? So that copper wire has a much higher tensile strength. And that's what we're talking about with these metals, the ability to resist breaking. Here is a picture of a bunch of different metals. Now, over here, steel. Over here, brass. Over here, metal sludge. Those are combinations, okay? So that's a little bit misleading because those are combinations of metals. But, bronze right here. I guess, hey, here's copper, here's aluminum, there's iron. Those are all elements on the periodic table. These other ones, so this might not be a great slide to put on there because a lot of those things are not metals that they're naming. But obviously the copper, aluminum, iron. You're going to find all three of those on the periodic table. Those are definitely metals. Another type of elements are nonmetals. Many nonmetals are gases at room temperature. Now, look at your periodic table. Find where the gases are. What do you think? Where do you think the nonmetals are? What side? The right side, because that's where the red ones are, correct? Okay, so those right side red ones telling us that they are gases at room temperature. Now, once again, it says many. It says many because not all nonmetals are gases at room temperature. Not all of them are gases at room temperature. Nonmetals are very poor conductors of heat and electricity. They are very poor conductors of both heat and electricity. They have a dull appearance. They are brittle. What's brittle mean? Yeah, it can break very easily. When I think of brittle, I think of peanut brittle. It breaks pretty easy. Boy, I like peanut brittle. To the left is sulfur. To the right is bromine. Both of which are nonmetals. Okay, both of which are nonmetals. Our third type of elements on our periodic table are going to be metalloids. Now, folks, these are all the types. So if you're on the periodic table of elements, you are one of three things. You are a metal, you are a nonmetal, or you are a metalloid. These metalloids, they are kind of half metal, half nonmetal. I've even heard at times metalloids being referred to as semi-metals. I've heard them referred to as semi-metals. So metalloid is an element that has characteristics of metals, but it also has some characteristics of nonmetals. So it's kind of a tweener. Kind of a tweener. Guess where they're at on the periodic table? In between the metals and the nonmetals. They're tweeners. The metalloids are solids at room temperature. They are all solids at room temperature. They are less malleable than metals, but they're not as brittle as metalloids. Or excuse me, of nonmetals. They're less malleable than metals, but they're not as brittle as nonmetals. They are semiconductors of electricity. So basically, metalloids are intermediates between metals and nonmetals. Metalloids are intermediates between metals and nonmetals. Now, I guess the big thing is now, let's determine what is where. Let's determine what is where. We've got properties of metals. We've got properties of nonmetals. We got properties of metalloids. But where are they at on our table? Okay. Well, there is a stair-step line that separates the metals from the nonmetals on the periodic table. Elements in the area of this line are often referred to as the metalloids. Now, if you look at your periodic table, the big periodic table I gave you has a stair step on it. The little periodic table only has the stair step on one side. So, if you were on this side, flip it over to the other side because the stair step is on the other side. Here is the stair step. Now, the way that I remember what my metalloids are, because metals are on one side of the stair step, nonmetals are on the other side, the metalloids are on the actual steps. So, if I look right here at tellurium, see how tellurium is touching that step, tellurium is touching that step. It is on that step. Tellurium is a metalloid. Whoa. Now, if you look right here at phosphorus, is phosphorus on the step? It is just touching the corner. Phosphorus is not a metalloid. If you look down here at tin, tin is just touching right there. Tin is not a metalloid. It is not on the step. Look at antimony, number 51, right here. Is it on the step? Is it touching the steps? Yeah, it's touching right here, and it's touching right here. That is a metalloid. If you can remember that, you can remember all the metalloids except for one exception. What is this guy right here? Aluminum. Is he touching the step? Yes. But what do we know about aluminum? It is a metal. So aluminum is our exception there. Aluminum is a metal. So if I go through, boron right here. What do you think is boron? Would you say boron is? A metalloid. We just talked about aluminum, right? What about silicon? What about silicon? Metalloid. What about copper? Or excuse me, carbon? What do you think carbon is? It is a nonmetal. I haven't said that yet. Nonmetals are on the right of the stair step. Metals are on the left. Okay? What about phosphorus? Nonmetal. Phosphorus is nonmetal. So, right here, gallium. What do you think about gallium? Gallium's a metal. What about that germanium? Germanium's a metalloid. Arsenic? Metalloid. Selenium? Nonmetal. Iodine? Nonmetal. Tellurium? Metalloid. We talked about antimony, right? So we look at that, we can tell. Now, let me ask you this. Down here, we talked about the lanthanide and the actinide series. What do you think they are? What do you think the lanthanide and the lanthanoid and actinide series are? Where did they fit in our table? Right by 57 and 89, correct? So what would that be? Metals. Okay, that would be metals. So now when I pull up this next slide, okay, I am perfectly fine if you want to code your periodic table like this. I'm perfectly fine with that. If you want to color code, this is your periodic table. If you want to do that, fine. If you don't need to do that, that's also fine. Okay? I would probably, if it were me, I might hold off on that because we might color code it differently a little bit later on. Okay? But notice, okay? Notice some of the exceptions. Hydrogen up here. Okay? Hydrogen is a gas. Hydrogen is a gas. It is a non-metal. We talked about aluminum, right? We talked about aluminum being a metal and not a metalloid like all the other ones, all right? So there are a few exceptions. Parker, you got a question? I consider these two as metalloids down here, okay? They kind of, it looks like they kind of half colored them, half not, okay? For our sakes, let's just consider them metalloids because they're sitting on the stair step, okay? Now, do you think that you could come in here and answer if we would list, okay, if I would put 15 elements on a piece of paper, you could come in here and you could tell me whether they're a metal, a non-metal, or a metalloid based at looking on your periodic table? Okay? I mean, that's the objective right there. Can I tell which is which? Which are metals, which are non-metals, which are metalloids? If the answer is absolutely, then we've hit our objective today. Okay?